Okay, welcome to the Spring Quarter Friday Transportation Seminar. My name is Chris Muntz. I'm the Civil Engineering Instructor of Record, and in the back is Dr. Wong. He's the USP Instructor of Record. So we just got a few housekeeping things to do before we start the seminar today. So we're going to pass around the attendance sheet. Make sure you initial. The class has a wait list. So if you don't indicate your attendance, you'll get dropped from the class, and then we'll add from the wait list. So if you're watching online, send an email to PSU Seminar so that we know you're watching online. So it's an important sign-in today, although it always is. So I'll start it here with Sam. And then just a couple things about the syllabus. If you're a civil engineering student, you should not be taking this class for pass, no pass, because it won't count for your degree requirement. I checked, and it looks like everybody's registered for a grade, so that's good for the graded portion. The syllabus, we passed it around. It's a pretty straightforward grading approach. Attend the class for 60% of the grade. You can watch some of them online. You will send us an email after you watch it online with the question. If you're in person, there's time for questions. So we need to know your name. We'll be in the back logging questions. So before you give a question, can you say your name so we can find it on the roster and log the question? If you don't have time to ask a question in the class, please write your name. Please write it on a piece of paper, write your name, and write the question and turn it in the back. But really try and ask a question in the class. I know well, it's going to be tough. There's 40 people registered in the class. So, but at least try and get two in a quarter or something. Then the rest of the grade is either a paper or a reflective journal, and the instructions are on the syllabus on what you need to write. Please don't write a summary of the talk, because I don't want to read 30 summaries of the talk. So add some reflection to it. Tell us what you think about it. And if you're registered for the graduate credit, the requirement is that you add 2 references for every reflection that you have. So you need to link it to a little bit more than just your personal reflection. So link it to some substantive talk. So, Liming, do you want to add anything? Did I forget anything? Right. You can watch the archive ones online. And for the final submission at the end of the quarter, Tuesday, 5 p.m., I'll take it in the Dropbox on D2L. Same thing. So any questions from students registered? All right, so we took away 3 minutes and 16 seconds of Joe's time. So, all right, so welcome to the Friday Transportation Seminar. We're very pleased to have our own, one of our own PhD graduates giving the talk today. Joe Broach is going to talk about rerouting mode choice models, some extension of some works that he's already been doing, and I'll re-look at it. So I'm going to turn it over to you, Joe.
All right. Thanks, Chris. It's always great to be in this room. I feel like great things happen in here. I did wonder a little bit about them needing an April Fool's Day speaker and thinking of me, but we'll see how it goes. So yeah, I'm excited to give you what is, for a few of you, I see some familiar faces. You've been following this series for a while, and I'm about to give you the latest installment in research on biking and walking behavior that I've been doing for a number of years. And since it is, an ongoing thing, I thought I would kind of give it to you as a story. So here's the latest installment in this research story. No one writes a good story if they don't have some motivation, and my motivations for doing this work are sort of threefold. First, and probably closest to my interest, is just a better understanding of behavior. And in this case, over the past, I don't know, probably decade at this point, we've been learning more and more about where people prefer to bike, and to a little bit lesser extent, where they prefer to walk. And my interest in this installment is, how does the quality of the places that people have to walk and bike affect their actual decisions to walk and bike in the first place? So we know quite a bit about the things that people prefer and the things that turn people off, but we don't know if it really affects whether or not they would have been biking or walking in the first place, or if they're just happier when they're on nicer facilities. So that's number one. Number two, I guess I can use the clicker here, is to inform policy. Right now, we're not at all short of enthusiasm for experimenting, planning. If you've been in Portland any length of time, it feels like sometimes there's a new bike or walk facility or feature, monthly at a minimum. but we're a little behind on the modeling side for the tools to sort of predict what effect these changes are going to have on people walking and biking, on the value to people of those things. So that's the second motivation. The third motivation is thinking more on a regional scale, and some of you may be familiar. This is, of course, a little bit dated, a four-step model of the way that we model regional travel behavior now and in the future. And the idea is trying to put biking and walking on a more level playing field with motorized modes. Most of this modeling began with driving and transit, and we're only slowly catching up with non-motorized active modes. That's the motivation, right? So let me catch those of you that haven't been around as long or got tired and quit reordering my series here, but let me catch you up on the story so far. So not just here, but in several places, starting about 10 years ago, the sort of technology and the modeling and research capabilities got to a point where we could start taking a close look at revealed preferences of bicycle route choice. So this evolved along with more portable GPS units. If you send someone out on a bike with a GPS and just tell them to behave as normal for a few days or a week, then you get a whole lot of data about the routes that they use, and also they kind of leave some breadcrumbs about routes that they could have used, and you're wondering why not. And the difference between those told us a lot about what sort of places people prefer to bike. These were people already biking, so keep that in mind. Then a few years later, here at PSU, we gathered a new GPS data set that was much broader. It was not just people on bikes, but it was just people in their daily lives for a couple of 5-day periods. And that meant from that data, we now had one of the first GPS data sets on just people's everyday walking behavior. And this is, my primary interest is in walking and biking for transportation, for utility purposes. We also captured recreational. So that was kind of some of the first, broad data on people's preferences of where to walk. So move ahead another year, and now from that data set, we had very comparable data on bicyclists from two different samples. The original bike GPS study data, the family activity study data, both included cyclists. The original one, most of them were into it. They were very enthusiastic cyclists. They volunteered for the study, and they had to carry around some pretty bulky units. So there was some questions about whether this really reflected broader preferences for different places to bike. With this new data set, which was, these people weren't recruited into a cycling study. These were families that were recruited into just family activity. They were less confident bikers on the whole. There was more in the interested and concerned class. We compared those and found that, in fact, preferences were pretty consistent between the two samples, that there was enough consistency in preferences for bike facilities that we really felt like we could do something to it, apply it more generally. So now we have a pretty good grasp, we feel like, on bike route preferences, beginning to get somewhat of a grasp on pedestrian route preferences, although that research is not quite as far along. And the last couple of years, and my dissertation was spent taking what we know about the routes people prefer, right, and putting it into a revealed preference mode choice framework. So now we're not just talking about this person is biking, and we observe that they prefer to use off-street paths or bike boulevards, low traffic neighborhood greenways, or they prefer to avoid hills or traffic. But now we're taking that information and saying, how does that affect whether or not they biked in the first place? So in a way, we're going backwards to go forward. We're going back to that decision when they decided to bike, or, importantly, not to bike for a given trip. That's the new installment. All right. So, as many of you know, if you've studied literature, usually there's a conceit, right? You have to buy into something if you're going to enjoy a story. And that something is probably not going to be 100% true, right? But if you get in that frame of mind, you get a great story, and hopefully you get a piece of the truth. It's worth looking at the world in this way. So here's my conceit, and I hope you'll buy in for now, and then we can have a discussion at the end about where you didn't buy it. Right? So the conceit is pretty simple. Right? This is my modeling framework. I say, given a trip from A to B, maybe you were somewhere else before you came here. Maybe you were farther downtown, right? Then my conceit is that in your mind, right, you may be considering different modes to get up here. You might walk, you might bike if you have a bike with you, you might drive if you have a car, you might take the streetcar or some other mode, all right? And as you're thinking about that, I'm thinking that you are also imagining the routes that you would use for each specific mode. So if I walked, right, downtown is pretty easy. You can just about take any street, be guaranteed decent facilities, right? If you bike, though, you may think, well, that means, I'd either have to use the park blocks, which are kind of slow and have a lot of tough crossings, or I could take Broadway up, but that's got a steep hill, and I don't really like maybe you don't like the cycle track, right? So this is the sort of conceit, and then the attributes along those routes that you're considering taking actually affect whether or not you bike, walk, drive, or take transit, right? So the hypothesis would be the higher quality the route, all else equal, the more likely you are to take the mode that uses that route, right? So that's the conceit. So here's the plot. Given a trip from an origin to a destination, right, we're going to predict the highest utility route, or you can think of it as the best route by walking or biking, right? So one for each. And then, I never thought I was going to be a best-selling author, going to estimate a maximum likelihood mode choice utility function, right? Which is probably not going to sell novels, but it's just a technique for inductively observing behavior and then imagining the preferences that would have been most likely to result in that behavior, right? So we observe the pattern of people choosing to walk and choosing to bike, and we also observe these predicted best walking routes and best biking routes and measure attributes along those, right? And the combination of the choice, right, and the environment in which they made that choice gives us a sense, right? It's not a perfect picture, but it gives us a sense of what is more or less important. And if we observe that thousands of times, right, then we start to see some patterns, hopefully. Right? So that's the plot. Given a trip from A to B, we add a new step. Rather than just looking along a shortest path or maybe thinking about a whole area, actually take another step and predict the best, based on route preferences, walking route. Maybe this one has a more connected sidewalk or better crossings at major streets. Predict the best bicycling route. Maybe it has a nice bike facility separated from traffic, maybe less steep, something like that. We then just measure for biking the attributes along that route, for walking the attributes along that route, and we also take into account the detour that was required to reach that best facility. All right? Making some sense? I think it'll keep making more sense as we go along. Every story has a setting, right? This one is here. Portland, because of this was a first try at this, data is a little bit stronger within the city boundaries, so I only looked at trips starting and ending within the city of Portland. In fact, staying within the city of Portland. And that way I could make use of all this great local data that we are so fortunate to have here from Metro, from the city of Portland, from others. A very detailed walking and bike network, which you see in orange there. Just, every alleyway, path, street imaginable is there. The facilities that are on that, and for cycling, for walking, right down to crosswalks and medians and things like that. And then the land use along there, so is it commercial, is it residential, how dense is it, and then the terrain, how steep or not is it along that route. So that's the setting. And then we have our colorful cast of characters. I mentioned the family activity study. So the people involved in this data that I'm telling you this research story about were drawn from about 19 neighborhoods, all on the east and north side of Portland. And I only looked at the adults in this study, although we also collected data from kids. Unfortunately, it's it's a typical survey population, which differs a bit from the broader populations, but useful for a first shot. So they are more educated, less diverse, more likely to be women, more homeowners. They do have a similar income to their sort of peers in the population, households with children. Slightly, actually, higher car ownership, and they do a little more biking, but also a little more driving. So in other words, less transit and walking than a more represented population would be. So keep that in mind. Like I said, this is one story, and it's not the whole story, but that's the characters one. But the real characters in the modeling are actually the trips that all of those participants took. And here is sort of some idea of the coverage of Portland that we got by mode, and you'll notice some gaps there that might seem a bit odd to you, and that's because the geographical sampling was not random. These were specific neighborhoods for the original study, and specifically they were neighborhoods that did not currently have a bike boulevard within them. Some of them were slated to get one, some weren't. That's neither here nor there for this study, but this is not necessarily representative, but just to show you sort of the coverage by mode and the data that I'm working with. So have all of these trips, and I also aggregated them into tours. Tours are just a chain of related trips. So maybe you go from home, you stop at the coffee shop, and you come to work, and that's a trip chain. It could even be farther than that, but I also took that into account a little bit. Right. So, as any of you have written, no. Right? Writing benefits from editing, and in this case, the editing was done on the data. We want to focus the story on what's most important in terms of better understanding walking and biking, and that means that looking at trips where walking and biking aren't really a realistic option, just sort of add pages without much content. So here you can see the distribution of distances in miles. I'm giving shortest path distances here, and you can see that walking falls off pretty quickly after about a mile or a mile and a quarter. Not unlike other studies have shown. Cycling just falls a little more steeply than auto and transit, and so on. The black lines there show you the editing that I did. All right, so I assumed that walk was an option if it was within the 99th percentile of walk trips, which was a little over 2 miles. Beyond that, it's considered that it wasn't a reasonable option for most trips. Same with bike. You can see the line way out there. I had to go all the way out to 7 miles to catch 99% of the bike trips in Portland. And so that was, that's my edit. I only looked at trips within about 7 miles and only looked at walk as an option for these distances. Now, after that edit, you'll see the curve shift a little, because now these are just trips that fit within that bin. And you can also see, so these are the colored vertical bars are the means in my sample. The corresponding arrows down below are the means from the same types of trips in the National Household Travel Survey, so nationally represented. So you can see that walk trips in my sample were a little bit shorter, bike trips were a little longer, auto and transit were quite a bit shorter, so we'll talk about limitations of generalizing this later, maybe related to Portland's somewhat unique urban form on the drive and transit side. But walking and biking, fairly reflective of NHTS in terms of distance. All right, now we get to the action. All right, so we have this setting and these characters and this conceit, and it's time for at least someone like me to get excited about building some models and thinking about different categories of model that I can build and compare. Right? And so the primary 3 models are shown here, just in terms of variable included. Each model that I looked at, and remember these are models of which travel mode you're going to use. So this is the choice, given that you're going from home to the coffee shop. Are you going to walk, bike, take transit, or drive? Those are the or ride in a car or drive, I guess, auto. Those are the only 4 options I consider. And so for all of the models, I included basic socio-demographics, like do you own a car, and what is your gender, that sort of thing. Also, trip context variables, like what's the purpose of the trip? Are you going to work or school? Are you going to the grocery store? Are you going somewhere else? The day of the week, how close are you to transit on each end of the trip? All these sort of things that are just sort of background to any decision. And then in each of the models, I added some things that got more at the travel environment, the things that you would experience along the way, particularly if you're walking or cycling, where you're kind of more exposed to the journey along the way. So in Model 1, what I added were just measurements of the distance of a shortest path, all right, and then measured different facilities and measure the travel environment within buffers around the origin and the destination. And this, in a lot of research on bike and walk mode choices, is the way that it's been done. It's fairly simple. You just draw a circle of a certain diameter, maybe half a mile or so around each end of the trip, and then you add things up that fall within it. So you add up miles of bike lane, miles of bike boulevard, you add up the average slope, right? All of these things, but they're all aggregated. And as you can see from this, a lot of the buffers maybe they aren't really relevant for a trip from A to B. They may be relevant for other trips. In the second group of models, I replaced all of those measurements with very similar measurements, but along those best routes that I showed you before. So now, instead of measuring miles of bike lane, I would be measuring something like percentage of the best cycling route that includes a bike lane, right? Or the terrain along that one route. Same for walking with sidewalks and paths and crossings and so on. Then I could compare those two, and then I also had a Model 3 where I combined the two. So to see if there's some independent information, does it maybe it matters what you experience along the route, but that area that you're coming from and going to may also have an impact on whether you bike, walk, or do something else. So soak that in. You feel that action? I can tell. All right, so then it's time for the big reveals, right? I'm going to spare you some of the modeling detail, but you are welcome to ask me questions and start me talking about that if you like at the end. Big reveal number 1. It does seem to be the case that measuring along that single best route, so that measuring attributes just around that red line, right, in this case for, say, cycling, right, gives us more information. It predicts the mode choice significantly better than measuring all of the same things around the destination and around the origin, on average, across all of these trips. So we do a significantly better job at predicting how you're going to travel for a trip by measuring along a realistic route rather than taking in the whole area. All right? And that's, to some of you, maybe you're thinking that's kind of obvious. It's more precise, more focused. But to be honest, I think it's kind of amazing that you can pick a route, predict a route, and get more information out of that tiny corridor than you can get out of this entire area. It's intriguing. Big reveal number 2, though, is that there was still information. There was independent information in those areas. So in other words, it seems to matter both that you have, say, an off-street bike path to use on a specific route for a trip. But it also does seem to matter just that there are bike paths or other nice facilities around the origin and destination. And now at this point, I can only sort of speculate, but one idea is that maybe that does help with trip chaining. So you're riding one route here, but if you're riding to a bikeable area, you can also use your bike for the next leg. Or if you're walking, that you can probably walk somewhere else. You're not going to hit a barrier where there's only one nice route from A to B, but then you're stuck, right? There's a freeway to cross or something like that. So that's one way to think about it. Maybe it has to do with habit in those locations. If it's a walkable area, you take other walk trips there. And so when you're taking a new trip, you think, well, try walking to start with. I don't know. It's going to take more research to really understand, but I think, again, an interesting result. Big reveal number 3 in this research story is that now we can say with some confidence that specific bike and walk improvements not only are beneficial to people who are already biking, so for choosing where to bike, they also have an impact on whether or not that person bikes or walks in the first place. So it's a little bit complicated. It's as simple as I could get it for today. But what this is showing, let's start with the top for biking. Maybe laser pointer dangerous. Yeah, okay. So what this is showing is that when one of these facilities is present, let's take off-street path, right? When it's available on that best route, right, a 10% increase in the part of that best route that uses an off-street path increases the probability of biking, right, by a little over 2%, right? Now that might not sound like a ton, but now think about in your mind if that trip is entirely on an off-street path. That's getting pretty substantial. And the same was true for bike boulevards, though with a twist, which I'll give you in a minute, with high traffic streets, which were not, they made you less likely to bike. For walking, off-street paths, again, very likely to increase the chances of walking. Arterials along commercial streets, like not neighborhood commercial, but large scale, were detrimental to choosing to walk. Same with missing sidewalk. And though it's not shown, arterial crossings without a signal were very likely to stop you from walking on a trip. Okay, so interesting. So what's the big deal? Well, the big deal is that a lot of these are policy levers that we can actually pull, right? Fairly, I don't want to, I don't want to diminish the difficulty of it sometimes, but it's fairly easy compared with, right, what we already knew, which is that proximity is very important, right? You see proximity here in each case has a strong negative sort of dissuasive effect of choosing to walk and bike. It's harder to bring origins and destinations closer together, right? I think any of us involved in planning or any related field know that it's much harder to change sort of the shape of a neighborhood so that it's denser or more mixed use than it is to build a decent facility to bike and walk between those 2 points, all right? So I think that's why this is sort of exciting, is that these are all policies, that we can pursue, and they have effects which, though not quite as large as proximity, they're in the ballpark. Like we can have a significant impact on sort of shifting trips toward active travel modes, which is beneficial for a lot of reasons by sort of pulling these levers. So this is big. It may not seem like a big reveal, but to those of us working in it, this is good news. It means that we're not just shifting people who are already biking around, and it's great that their route is now better. It's a benefit to them, but it's saying that we can possibly increase the number of trips by walking and biking. Big reveal number 4. In the revealed preference route choice work to date, we have not seen a gender difference in preferences. We know that there's a gender gap in general in cycling in the U.S. and lots of other companies. Men are more likely to cycle than women. But in route choice, we haven't seen it. But remember that those are people already riding on that trip, right? So we're not getting the people that at home thought about the route that they were facing and decided, nah, I'm not going to bike on that street, right? So now we're talking about that decision of whether to bike, and there now, for the first time, sort of seeing a revealed gender preference difference in a number of dimensions. All right, so let me go through each of these 4, which are kind of interesting. First of all, for a similar trip, right, controlling for all of these things, the quality of the route, sociodemographics, terrain, land use, the trip purpose, day of the week, all this stuff I've been spouting up here, controlling for all of that, women are about 38% less likely to choose to bike on a given trip. Right? So that's sort of the basic, that's that intercept, right? That's the gender gap. But there are some other things that either make it, that widen it, right? But other things that bring it together. Something that widens it is when the best cycling routes, the route that a cyclist is most likely to choose, is along even moderate traffic streets. So we're talking about, not the largest arterials. These are streets with 5,000 to 20,000 cars a day. So all the way down to the level of I probably can't name enough to sort of to help you out here, but in my neighborhood, it's like Milwaukee Avenue. So these more minor but important streets. 52nd Avenue, where the new bike lanes went in, would be another good example. Not the ones that are obviously, would be a challenge to bike on, like West Burnside, but even moderate traffic widens the gender gap. Women less likely to ride. Men maybe less happy, but still just as likely to ride. All right. And bike lanes here, just the striped bike lanes, no significant impact of offsetting that traffic. So that also differs from route choice work. Some better news: when the best route, and this would be rare, of course, but if it were entirely along a bike boulevard, right, then that would essentially be predicted to close the gender gap, right? So that's a 68% increase in the chance that women cycle. In other words, offsetting this basic gender gap. Now, of course, it also is impactful even if half of the route is along the bike boulevard. It doesn't have to be all of it. I'm just giving the kind of the outer bound. So these low-traffic streets, those of you not familiar with bike boulevards, these are low-traffic residential streets that have been improved for cycling and walking. So there's traffic diversion. They keep the traffic speeds and volumes lower than they otherwise would be, and kind of prioritize bike movement. So these low-traffic stress routes seem pretty important for closing that gender gap. Now, here's a weird one. Why is 0%? What does that have to do with the gender gap? You can read the fine print and see that this is one that still trying to understand, and there's clearly more to it. But for trips that cross the Willamette, so that have a major river crossing where you have to ride across a significant bridge, right? Those trips are more attractive to cycle for men than the average trip, right? Probably for lots of reasons. Maybe because it's more competitive with driving when you're crossing a bridge, which are congested points in the road. For women, there's no significant impact. So they're neither more or less likely to ride on those trips. So that it widens the gender gap, even though it's showing up as 0% here. I've had some interesting discussions with people about why that might be, because I'm already controlling for things like the trips going to the central city, the obvious things, the quality of the facilities, and what I've heard most from people who I've talked with, and I've also heard these things anecdotally. It's just that the bridges they're also kind of congested places for cycling, especially at rush hour. They're just not as comfortable as the same facility off of a bridge. And then there are the approaches to the bridge that maybe my data is not giving enough weight to. I hear that these connections they're not comfortable. They're hard, high traffic stress, even though the numbers may not quite be there. So I don't know. I welcome your suggestions to that too. It may be that it's the result of something else I'm missing from the model. Big reveal number 5. I hope there's more to it. Good. I was a little worried. I don't remember that. So this form of modeling, right, it fits a little better. It's a little better at predicting. I mentioned that. The difference is not huge, though, but where the real difference comes in with using this technique of looking at predicted routes rather than whole areas is that it becomes a lot more sensitive to those policies. So I want to just give you a quick example here. So take this example of, maybe these are 2 points that we really want to connect. It's PSU, or the new OHSU campus, with a major residential area. And right now, the sort of best path is Route 1 at the top. It follows the shortest path, but it's along a busy street that has a bike lane. So, something like Hawthorne, for instance. There's an alternative route, Route 2. It requires you to go 10% farther, but it puts you onto quiet local streets. Now, the route choice work that we've done suggests that most cyclists are going to follow Route 1 in this case, that just a quiet street is not enough to offset that 10% detour, right, when you're actually out there and pedaling to work or school or wherever. Right. But now, imagine that we were thinking about trying to improve that alternative path. Maybe someone was sitting in here and saw the potential for bike boulevards. I hope so. And they wanted to know, well, what if we put a bike boulevard along Route 2? It's still going to be longer, but it might actually get cyclists to use it, And if they're more comfortable with the idea of taking that trip along the bike boulevard, it also might make them more likely to cycle. So now, if you look on the left side, this would be, in this situation, for a 2-mile trip, the initial probability of choosing to bike, given that the best route is Route 1. Right? So in that buffer model, remember that I showed you with the circles and we measured the miles of bike lane, right? You can see that predicted percentages are pretty low. In the route model, they happen to be a little higher because they're picking up some different factors, but they're roughly comparable. It's pretty small odds of biking for the trip. Right? Now, consider that we put a bike boulevard along this entire length of low volume street. And now, I'm sorry that I changed from buffer to area here on you, but it's the same thing. Right? Now what happens is, in our route model, the best route shifts. So now the route that we would predict cyclists to use is here along the bike boulevard. And look at the difference in the change, right? Just a very small change in percentages for the area model, but the route model, very sensitive to the fact that the best route now is low traffic. It includes a bike boulevard, and the detour is not that great. Right? So all three of those things are sort of, in a way, you could say this. The model's more sensitive to it, right? It's better designed to pick up these sort of small changes, because you imagine this change is pretty small within a half-mile radius. Right? It's just it's 2 miles of bike boulevard. That's pretty much all it is within the origin area or the destination area. But here we're saying, no, it's the actual useful route that you're going to consider riding. Right? That's the sort of trick. And this is an example of where, if you were using a buffer area-based model, you'd say, yeah, I don't see this as really creating a lot of new bike trips. You may still want to do it just to improve things for existing cyclists, but it'd be a harder pitch, right? This would be a pitch that you could make. Now, this is preliminary, right? Don't tweet out these numbers. But it's preliminary work, but it's just showing the potential for much greater sensitivity to the sort of policies we want to be able to consider, right? We want to know, do we want to put a bike boulevard here, or should we put one here? Is this too far out of the way? Same for walking, right? Where should we put the improved crossing? This sort of thing. So we're getting there, I think. This plot twist. What if all of this facility stuff is just because the people that already want to walk or want to bike choose to live in neighborhoods with lots of biking and walking facilities, right? That's a problem that we face in this sort of research. We can't say for sure that just because these people tend to have a bike boulevard available for a trip, and we observe they're more likely to bike, but what if that's why they're living there, right? Because these facilities are all around them. So fortunately, we asked, at least we got a start on that because we asked some specific travel-related residential location questions. We asked people, when you were choosing your current home, how important was it to you on a scale of 1 to 5 that it was a good walking neighborhood or that it was a good biking neighborhood? And you can see the means are fairly high. This is East and North Portland. But could then use that to kind of control to some extent for that self-selection effect, right? And see if there's still an effect remaining. And indeed there was, though it was significant. So we were definitely measuring something, right? So each point increase on that scale, so if you went from a 3 to a 4, would result in just, on an average trip, of a 22% increase in your chance of walking, 39% increase in your chance of biking. These are percent, not percentage points. So if it's 10% to begin with, this is another 2.2%. Right? But the sort of significance and magnitude of those route attributes were pretty much unaffected. They were still important. So though you were more likely to bike on the whole, so you're just on any trip, you're more likely to bike or walk if you chose that neighborhood in order to do so, the facilities still had about the same additional impact. So if you chose a neighborhood and you have a bike boulevard available on the trip, you kind of behave just like someone who didn't choose that neighborhood for biking. And that also, I think, is a positive result because it gets around that, sometimes you get some naysaying around, well, people are just living in these bikeable places because they want to bike. That's all you're measuring. it seems like we're measuring something more than that when we measure quality of facilities. So plot twist resolved. So, you know, those critics, they always find something. And there's certainly plenty here that is either preliminary or that's going to be in the next installment, right? So one of the issues I've talked about a little bit is just that these are trip-based models, so they're not taking into account that you may have your whole day planned out when you're making that first trip decision. So I'm observing you coming from home to school, but in your mind you're thinking about going to the rock gym after school, and you're thinking, will the bike work for that? Will walking work for that? Transit auto, right? Now, I did try to account for it a little bit in at least considering the total tour. So that the whole distance from home to school to the rock gym back home, I accounted for that. And that did have significant effects on whether you would bike or walk, just that you're thinking about the whole day distance, not just each leg. Right? But it could be improved in more of a tour framework context. I sort of assumed this order. That was part of my conceit, right? I sort of glossed over it, but I said, given a trip from A to B, right? But what if it's actually given that you want to take a bike trip, where are you going to go? Where is B, right? So you could think of that a little bit the other way. The bulk of research has shown that this is the sort of stronger direction, but it's certainly not 100%. That's why it's a conceit. All right? There's probably some interplay in that you're kind of leaning toward walking, and then you think, are there destinations that are more walkable? So it may not be a perfect sort of conceit there. This was panel data, so I was observing the same person taking a number of trips. Due to sample and modeling limitations, I wasn't able to completely control for those person-specific effects. I did do my best to control for the time effect of the panel, so I had variables that captured which wave that they were in, just in case, conditions were getting better in general, or people were biking more for whatever reason. At least I captured those time changes. I used a single best route. I saw a few of you kind of, looking at those single bike and walk routes and thinking, that seems a little simple, let's measure one. To be honest, that was, computational for a first stab. It's hard to find one route, right? It's really hard to find the 5 best, the 10 best. Right? It's tricky. So that'll come, but right now, at least it showed some promise in that measuring that, the loudest signal got us somewhere. If we start to measure a little more of that signal with more routes for more people, then I think we can do better. I have to admit, I kind of like this limitation. As someone who's been working so hard to sort of catch biking and walking up to the other modes, it's sort of fun to say, well, my transit and auto modes are kind of limited. I mean, they're just kind of hard to model. So, yeah, but it is true. The transit and auto they didn't have all the variables in there that you would love to have. I didn't have exact parking costs. I just had if it was in the metered zone or not, right? And I didn't have congested travel times. I just had shortest path distances. So there were some limitations there. A really important thing, revealed preference work is really powerful because people are acting, we hope, sort of naturalistically, right? They're going about their day and we're observing what they do, rather than sitting them down in a lab and asking, what would you do if you had, a new bike and walk-only bridge to use? Right? So it's a different context, but it's also limited in that we can only observe them within the context that that exists, right? So I observed people in Portland. There were certain trade-offs that just didn't get made. One thing that was really important in the route modeling was the facility on a bridge. Was it separated? Was it, or at least a bike lane? Was there nothing? When I got to the mode choice model, the problem is in Portland, the way the network is structured, every trip across the river could use a bridge, within a reasonable detour that had a separated bike facility. So there was nothing to compare it to. Right? So I really can't say anything about the impact of bridges beyond a trip across the bridge had a certain factor, but I can't say that this is the mode choice impact of a separated path bridge versus something else. That's something that we could probably pick up better if I didn't use that single route. There's an example of that limitation. And then finally, aside from the self-selection that you might consider a little bit of an attitude or an intention, Attitudes weren't explicitly included here, so I wasn't taking into account, that maybe people were more likely to walk or bike because they thought it was good for health, or they just thought it was, they have pro-environmental attitudes, they think it's good for the environment, that sort of thing was not picked up explicitly. Right? So, stories sometimes have morals. That's a little strong in this case, but I thought I'd take it to the end here. These are sort of what I would take away from this preliminary work. I think, the first thing is what I've already said, that the quality of bike and walk routes, they don't just affect where people ride and where those people already riding benefit, but they're also likely to increase the number of walk and bike trips that go by bike and walk. So it's not just where, it's also whether. Secondly, it's another feather in the cap of these low traffic stress facilities. They seem to benefit a broad range of users, and specifically they seem like they may be particularly important for closing that gender gap and encouraging more women to use walking and cycling when it makes sense to. Finally, I think it is I didn't go into much detail, but I mentioned I captured those detours, right? So not only the attributes along the best routes, but also how far you had to go to get to a good route. Right? And the detours were important, so I would say that, for maximum value, you want to start on that shortest path and try to keep it close to that. Right? The detour sort of diminishes the impact of even a really nice facility. So you've probably been in the situation where you could use the Springwater Trail or a path, but you're like, the access is way over there, I think I'll just ride the street. Right? So that seems to be true when you're thinking about whether to bike. If you have to go a long way, it doesn't have the same impact on you choosing to bike. However, right, that impact does extend pretty far from the shortest path. So there's still something to be said about putting an off-street path or a boulevard or something else in even if it's a little bit of a detour, particularly if the alternative routes are really bad. All right, in that case, you can see something like I showed in the example where it could have a big impact if the alternative is really lousy. Then even if you have to go an extra 50% even or more out of your way, these facilities the model showed still had this sort of positive impact or offset negative. And that's the end of this installment. I hope that it looks like we have some pretty good time for discussion, and you're also welcome to get in touch with me. Before we go to questions, I will add in my contact info and also the references, so you can go and read about those steps along the timeline to the one that gets posted on the site. So you can check some of that out or get in touch with me if you don't get your question answered today. So thanks so much for following along. I hope that sort of worked. I just felt like we should do something a little different for April Fool's Day. So there we go. So I'll turn it over to questions.
Remember to say your name if you want to check you out.
Yeah, up front.
Melissa Weston, have you guys worked with Better Block at all? Because I know they've been doing because there's a couple projects going on with Capstone right now that they're making cool things.
I have not. I'm aware of what they're doing, and it's pretty. It would be pretty interesting to. I don't know if anyone's been doing any intercept surveys along those blocks where they've been doing it and asking about. How would you have taken this trip before? Did you just change route, or would you actually have gone by a different route?
Seems like there's a big opportunity there for more research once they...
Yeah, I think so. I don't know how much the newness and promotion. Maybe we need each day we promote a bikeway on Twitter or something and say, check out the Stark Street Bower bike lanes. Yeah, maybe some promotional aspect there too. But that's a good thought. If no one's doing that, we should find someone to do it.
Hey, I'm Tracer Burge. How much do they change the speed? You said on bike boulevards they change the speeds a little bit. What's the deal with that?
Well, they try to maintain the speed a little more so than that. I guess there are the 20 mile per hour streets now, which they're trying to do on neighborhood greenways, and it's not all of them. But they also monitor the speed and traffic volume at more regular intervals, and if if speeds or volumes are getting too high, like this kind of happened I think in Clinton, then they come up with treatments that will hopefully bring those back down to closer to the posted speed, right? Or to 20 miles an hour if that's the district. Yeah. I'm not an engineer, so I can't shoot perfectly, so we'll have to fight about it. Yeah. But that's the basics. Yeah, right behind you.
Come on, okay, it's here. Do you ever look at seasonal variabilities and how that affects people's selection of the modes?
Yeah, I have not. Others here have, including I know Krista Nordbach over at Trek has done some work there. I mean, obviously there are some effects, even in a climate that's fairly mild. This data was pretty much all collected in the nice season. This was collected from mostly May through October, so in those warm weather zones. But you're right, that's a challenge going forward for non-motorized modeling, is that we more than some of the other methods have to really account for those micro effects of it's threatened to rain today, or it's cold, windy. Now you're right, and this did not account for weather. Yeah, in the green, I guess. Sorry, gold.
I'm Emily Haley-Panofsky. When you were talking about you checked to see if they had cars with the data and everything, and then from the bike data, those people are already biking. But did you also see if they had availability of having a bike for any of the other? Was that a part of it too?
Yeah. So for the route choice work, they had a bike because they had to put a GPS on it. So that was a given. For this, it was one of the criterion for participating was that you had access to a working bicycle. So so we could assume that a bike was at least some sort of an option for everyone. They didn't have to have ridden it in any recent time. And the truth is that I was involved with the actual recruitment and collection, and it was not much of a barrier in Portland. It seems like almost everyone. Some people would even pause at the question like, "Oh, I do have one in the garage." So they hadn't ridden in a while, but they all had access to the bike, or should have. Yeah, it's a good point that I didn't raise. Yeah.
More pages. Sorry about that.
No problem.
So, okay, there we go. So regarding the gender gap in biking, it's probably not part of what you were studying here per se, but it seems like social attitudes regarding gender norms and stereotypes might play into the reduction in women bicycling compared to men.
Yeah.
Maybe bicycling to be non-feminine, tomboyish.
Yeah.
And that maybe in broader sense to people identity as bicyclists and as just being out in public, kind of vulnerable on the streets like that, plays into whether or not they will actually pursue biking or walk.
Yeah. You're clearly onto something there. Though I haven't worked directly in the area, and Jennifer and some others have looked into these issues. And like I said, attitudes missing is, not ideal. It's the next step. And one question is, gender may just be proxying for all these things, probably is. And one next step that we really want to take with this research, me and colleagues, is to look at how gender interrelates with sort of the type of cyclist you are, and that's getting, I think, at what you're looking at. So I don't know if you've heard of those categories of from no way, no how, and interested but concerned, and so we may just be picking up some of that in the.
Just seem like other research was do kind of in parallel.
Yeah. Oh, totally. Yeah. The facilities probably have an impact, but in that sort of first nudge, though, like I'm gonna seriously consider it. That maybe that's where those social norms and attitudes are so important. But you picked up an important missing point there. Thoughts or questions? Yeah.
I'm Tori Abrams. So I have a few thoughts about connectivity on routes themselves, specifically from the Hawthorne Bridge coming towards Portland State. Mm-hmm. If you're coming, you get onto Main Street from the bridge, and you have this mostly protected area on the bridge, and then before that, it's just you have pretty much no projection at all once you get off of Madison to the Hawthorne Bridge. But then you have basically two routes once you cross the bridge to get to Portland State. Mm-hmm. You have the one on 5th, which is you have
left side,
left side bike lane, and then there's that little protected section by the light rail station at the end. Or you can go all the way up to arguably the safest area to bike to Portland State, which is on the cycle track. This is completely separate area from Broadway. But like that area between like that area on Main Street that connects to Broadway is so unsafe like all the time. There's almost no safe way to turn left safely.
Sure. I know.
How do you think that connectivity would play a role in getting more people, especially like students, to bike to Portland State?
Yeah, it's an interesting thought. I mean, it's there in the model, but I think you're onto something with that harsh transition. I'm especially aware of it. I ride that route a lot of days, and so you kind of get to where you just get used to it. But when I have someone visiting and I'm riding them downtown, that's when I realize that, like, man, this is the pavement's super rough. There's transit crossing paths. So there's probably some sort of more non-linearity to it when maybe you come from a nice facility and all of a sudden it just drops to just no protection, like you said, and then you have to make a move to make the other one. So there are some things along that would be captured in the model, but I think you may be right. It'd be interesting to test to see if there's something with just counting these transitions. How often does it switch? Because that takes more mental energy, right? If you're going from, oh, this is pleasant, oh my gosh, oh, okay, it's better again, no. And then the route finding itself, you're just figuring out how to do that the first time is maybe not easy. Or in your mind, when you're like my pondering man here thinking, what route would I use to get to PSU if I bike? Well, I could get to the Hawthorne and then do some leftish, or I like that a lot. Thanks for the thought. I can't give you specifics. I think, but I do think it's important. Yeah.
One question here, Kamal. So you said between the buffer model and the route model, two different approaches. The route model or the buffer model said you're going to add up all the miles of facilities that we have.
Right.
Whereas
the
route
like
model.
that,
So route model, I'm assuming that you're going to rate. You have a categorical ordinal.
Yeah, I tested a large number of things, but in the end, what it usually comes down to for facility is just the proportion of a route that's along a certain type of facility. So this route is 20% busy street, 30% bike boulevard, 20%. So that it comes down to kind of the proportion of the route that's along that, rather than the proportion of the area. That's the sort of the difference. Then,
Since it's still a course resolution, it seems like along the route, you can add up all the facilities, maybe have better rating for that route, and better.
Are you thinking about getting down like below the route level, like link to link, or what are you thinking about?
Maybe we look at, she was saying the connectivity a little bit, and just even the number of facilities, because sometimes, riding up Ankeny, crossing 20th, and then after that you get up to 28th, and you have a hill, maybe you want to turn right and take 28th, Stark instead of, you know what I mean? So the number of facilities that do occur along the route.
This is something that I had not completely considered. The model certainly takes into account, how contiguous the route is. Like, do you have to make a bunch of turns to stay on it? But it doesn't really pick up the change in the level of facility, or even like the change in slope. I don't know. This is something that I'm going to look into, and that's why I like to do presentations this room. You have one from the web?
Wrap up with a
Sure.
So, did you have any unanticipated factors that you added in your model, like construction or bridges being closed? Were you not able to?
Let me think. I'm sure there were predicted. The bridges in general it was a surprise that the river crossing still had an impact after controlling for what seemed to be all of the aspects I would expect. I didn't have such detailed data like where things closed. I only updated the facilities, and the data only really supports updating it every year, so that I had what was it like in 2010, 2011, 2012, but I didn't have those. It is true for that trip, though. If the steel bridge is closed, I'm considering it's an option. Man, that commenter will have to email me, and I'll go back through my notes. There was a lot of modeling went into what you've seen here today. Thanks for the question.
All right, so the speaker next week is Joe Forbright. He's going to be talking about the myth of Oregon's freight-dependent economy. So with that, let's give Joe another round of applause.